Thank you for being here. As I mentioned, I'm going to speak on an ongoing project. Jhonathan. Sorry. Um, this is an ongoing project in Melbourne where we are aiming to increase our capability to observe and measure methane around the urban region. And just a little bit background because Jocelyn did a really good job at this. We're focusing on methane very much because it's the second largest contributor to climate change, but also because it has a really lower lifetime than CO2, giving us a chance to actually decrease emissions and see an actual effect on the concentrations in the short term. Based on that, in 2021, the world committed to something called the Methane Pledge. We're trying to decrease methane emissions by 30% by 2030, and Australia is not assigning it since last year, so we're focusing efforts to achieve this goal. Now, the question is, how well do we understand methane? And here, I'm just going to bring two plots from the International Energy Agency showing on the first one two different emission inventories. One is there reported to the United Nations, which is a light blue, and the other one is just different emission inventories reported that are usually based for the models, say EDGAR, CDAS, or other sources. And just here you can see the difference that Justin mentioned before. There's a huge discrepancy in different sectors, and this is just the average, so the actual range is pretty much bigger. So we don't know much of, well, we know something, but we need a lot of work to do. But also there is a lot that is not included in those emission inventories, and this is just an example of it. This is emissions captured by satellites, not reported, usually super emitters, and you probably have heard of them. They've been in the news in the last couple of years, and this is something that came out in Australia, showing that we are actually underreporting emissions. But it's also appearing in different sectors, like US has found that wastewater sector is also underreporting when they're a factor of 2, and even the cooking sector, landfill, or even just leaks from the natural gas systems in the different cities. So how can we use the observations to improve our emission inventories? So pretty much we have this report that usually we have at the city level with unknown uncertainty, because sadly we don't they don't report the uncertainty given that all the different problems that Jason mentioned. But we do have, or we're trying to implement observations in different scales to have a better footprint of what's going on in a specific area. So we put that together with what is a meteorological model that is going to recreate how the wind moves, and we put that in a numerical model to recreate, go from the observations to what's coming from the ground. So we go from the air to what's coming from the ground, and we get something like this, which is an emission inventory disaggregated by sector and with a spatial distribution that is useful to make decisions and actually guide policy. And the beauty of this is that this is a loop or a feedback process, and once we get this with this posterior or output from the model, we can put it back in with new observations and get an even better result. So in conclusion, as a brief resume, we get better emission estimates that increase uncertainty, so that will actually improve the models that we're using for predict emissions. Now, the next question is why urban observations? So the main point is we need to reduce emissions no matter where, so any contributions that we do is actually useful. But the second point is that, as we know, cities are the big hotspots for emissions because most of us live in cities, and this is growing with each year that's passing. But also with the growing population, services are more in demand, and usually our emissions are associated with these services. So it's so big that actually 20% of the emissions of methane is supposed to be coming from cities in just 3% of the land surface. So there's a huge challenge here, but as they say, with challenge comes opportunity. So there's a lot of things to do to actually reduce emissions from these multiple sources around the city. Something else that we want to account for is that urban observations provide information at different scales, and it's usually suitable for city users and decision makers. So on the side of the city users, people can actually follow up and be informed of what's going on in the living places. and for decision makers, they can create policy and follow up of what's going on around them. And finally, as I mentioned, and just not to leave it out, is actually what we are going to use to support emission inventories in the future. Now, going to the specific topic here, this is our current observation network in Melbourne. Is the big map on the right side, but I'm putting here one of the stations of the Australian greenhouse observation network that's located in Caldow, south in Tasmania, because we use that information to get a baseline of what's going on or what's coming into the area from the Southern Ocean. And in those sites that we have on the right, we are continuously measuring CO2, methane, and occasionally CO, depending on what we are aiming to get at each specific site. So as you can see, we have a few sites. They are concentrated in a specific area of the city, and this is not coincidental. We have 2 sites of CSIRO there, so it's easier to deploy something in something that you own. But also we have 2 specific sites that are in collaboration with different institutions. One is the red one that is next to a water treatment plant, because we have some interest in understanding how the emissions change with time. But also we have one in the middle of the city that is a blue star on top, which is in collaboration with Melbourne Uni, trying to capture more broader scale things in a really, really high building. Now, I'm going to show why we want to have different types of sites. And here I'm just showing the difference between the site that is next to the water treatment plant and one that is a little bit far away. And you can notice the difference in the different peaks that the observation capture. So pretty much they're overlaying, so that's good. We're seeing the same things, but we're seeing in a different scale, pretty much because the dispersion is getting or showing less emissions or less concentrations at different points that is far away from the source. And this enhancement could be from 1.5 2 times to up to 10 times. And this is giving us information that there's actually a big source next to this, the source of the analyzer that we're seeing here. And we can use other analyzers to actually attribute that emission to specific sources. So here, this is just an example of comparing methane with N2O that's usually associated with microbial activity. And as you can see, a lot of these peaks correlate quite well with enhancements in N2O. So we can say with some confidence that the water treatment plant is driving some of most of the methane emissions in the area. And we can corroborate that with some mobile surveys and isotopic composition. And I will go back to that. So how do we select new sites? Pretty much it's a matter of location. Well, you want to have in mind areas without coverage because, well, you want to see as much as you can. Also, meteorology in the local scales is quite important. You need to understand what is upwind and downwind of what you're measuring. And of course, the accessibility of location. You want to put your instrument somewhere safe where you have access to it and you have power and it can keep sampling all the time. Finally, and this is really important, representativity of what you're seeing. Depending on the objective of the actual site, you want to consider different actual positions or places to deploy the instrument. Mainly, the height of the sampling line will make a big difference in the whole footprint that the instrument will see. Or if there are nearby sources like what I mentioned in the water treatment plant, if it's interesting to you, you want to go closer to it. This is just an example of what we need to actually select those areas that are highlighted in the map, which is where we are aiming to deploy new sites. We use meteorology, I think it's 15 years back, to understand what's the actual main driver of how's the wind behaving at different seasons, and just to understand if we were actually having emissions move from the city to other places or coming to the city. And pretty much it changed between seasons. So you will expect, this is something that is not unexpected during the summer. We have southerlies coming into the city, so it's something that there will be much emissions coming to it, but it will be transported to other places. But in winter, we have contrary, so there's winds coming to the city, so there might be some emissions coming from the north part. The shoulder months are a mix. It depends on what's actually happening. Most of the emissions, well, we don't know, but the winds are coming mainly from the west. For some cases, it will come from the east. And given that this is actually a 15 years average, it doesn't represent what is actually a measure scale of what's happening on the small areas. So probably use this as a guidance tool, but as a guidance to actually deploy stuff. And to this point, we have a network that can give us an idea of what's going on, but it's not giving us an answer of what's actually coming from the city. And this is just a map to make the point that cities are really complex, and it's just highlighting all the different sources that we can see for most of them reported in the official data. And I just put this here because we are using local information to guide our mobile surveys. And I just moved to that. And we're using a small portable analyzers to see what's coming up from different sources. And what we can see, what we're doing is just measuring around and having a picture of what's coming up at different places to have an idea of the actual spatial distribution of the emissions. And you can get things like this on the top, where you have enhancements, and with different tracers, we can actually attribute those emissions to specific sources. This is my last slide, so just like some conclusions of a brief resume of the presentations. We are increasing our sites. We have a couple of new sites planned. We are now speaking with councils to actually deploy those instruments in a specific sites that are of interest. We have some more analyzers, not only of methane and CO2, but also for isotopic composition. Also, we're using Raven to actually try to characterize PVL profiles, and we have some other stuff for model surveys. And we have some complementary projects that are going on, trying to increase or create more pictures that similar to what I mentioned before, to better improve our spatial distribution of the emissions. And that's me. Thank you.
Thanks, Jhonathan. Do we have any questions?
Yeah. So in that last map, you showed sewage pipelines and LNG. Is there natural gas going to residential areas in Melbourne?
Yes, it is.
And is that's probably a pretty significant source?
Yes, the black lines are the natural pipe gas, and the blue ones is the actual sewage, the main pipelines. At this point, we don't know. It seems like sewage and the water treatment plant is actually driving the emissions next to Aspendale, which is a small region, but we are still working on trying to measure this all around the city to have a better idea. So he did some analysis before, seeing how the emissions being reduced, which seems to be correlated with the improvement in the natural gas pipelines. And so we are not really sure, but we attribute that we actually fix some issues, and now we have less emissions in the area associated with that. But yeah, huge reason.
Yeah, Melbourne has a lot of reticulated gas for heating and for cooking, and from some work that's been done out of UNSW here and work we've done out of Aspendale, we definitely have a gas problem. I think in Melbourne it's probably less bad than it is in Sydney, but a lot of the methane we see is coming from reticulated natural gas leakage. Yeah, using our. Sorry. Are there any other questions before we move on to the next speaker? Okay. Well,
one quick question. How much does the sensor cost?
It depends on the sensor.
Sorry, just quick question. How much does the heat sensors cost?
It depends on which instrument you want to buy. The ones that we use in the Krummel are more expensive than the mobile ones. We recently purchased one of the mobile ones, and that was around $40K US. But the other ones are really more fancy. You would go to 100K? Yeah.
they're not cheap.
Yeah. So yeah.
Right, thank you.